Okay, in part B, they're asking us to interpret what this means. So in part B, what does it mean? So it's the instantaneous rate of change for every annual interest rate. So obviously will be a increasing situation, right? Because it's a positive. R cannot be a negative value, although it could exist though, but so R is a positive value. Even if it's negative, this is still a squared quantity, so this will always be positive. So in this situation is the instantaneous rate of change of the amount of money with respect to the annual interest rate. So because the annual interest rate is in percent, so the measurement unit of this will be dollars per percent. And it's increasing. In other words, as we increase the percent by 1, we increase the amount by whatever that is, calculated for every R. Okay, let's look at consumer demand. Problem 80.
For the last one, you said increase what by 1? That would give us.
So if it's like any slope, this is not a slope, right? It's not a slope because this is a different function. It's not a linear function, right? So as we increase the interest rate by 1%, the rate of change, the amount of money increases by whatever we get. So if R is 2, then I have 3 to the second power, which would be 9. 9 times 3 will be 27,000. So for an increase of 1%, we will get an increase of 37,000. For every dollar increase. For every percent increase, this is the amount that our accumulated value increases by.
I'm good, thank you.
Thank you. Okay, problem 80, consumer demand on 165. Suppose the demand function for a new autobiography is given by demand function of price, 80,000 divided by P. You know I'm not going to use this. I refuse. No matter what they are asking me to do. Unless they're asking me to evaluate, then I will punch this in the calculator. That price P is a function of time. Okay, and P is a function of time. So P of T is 1.6 T plus 9. Where T is in days. T in days. Price. What else they say here? The demand function for okay, and good, that's it. Find the demand as a function of time T. So in part A, they're asking us to find D as a function of T. How do I do that? Anyone?
You plug in for P?
Of course, yes. So I will say this time that this is D of T, and I have 80,000. In parentheses, I put 1.6 T plus 9 raised to negative 1. This is the demand function of time. Part B. In part B, they say, find the rate of change of the quantity demanded when T equals 100 days. For T equals 100 days, we are asked to find D prime, the rate of change, when T is 100. What do I need to determine first?
D prime of T.
Of course, thank you very much. D prime of T indeed. Can anyone help with this?
negative 80,000.
Very good. Negative 80,000.
Into parentheses 1.6t plus 9, so negative 2 times 1.6.
Awesome. That's it. I'm going to multiply 1.6 by this. So what do I get? 1.6 times 80,000. What is it? 128,000. So negative 128,000. Of course, everything divided by 1.6t plus 9 to the second power. I need to have the equal symbol and the negative symbol right in front. Oops. Okay. So everything has to be lined up. The equal symbol, the negative sign, and the fraction line, they all have to be lined up. Okay, perfect. Good, so now all I have to do is just plug in D prime, I will plug in 100. So negative 128,000 over 1.6 times 100 is 160, 169. And it has to be squared. Careful how you punch it in the graphing calculator. So it's 128,000, I already have it, divided by, in parentheses, 169 squared, and divide. So I got negative 4.48, approximately negative 4.48. Without a measurement unit, it means nothing. So the measurement unit for D over the measurement unit for 100. So what is the measurement unit for D?
Demand.
Very good. Units. Awesome. Perfect. Divided by the measurement unit of T, which is?
Day.
Days.
Very good. So what does this mean? It means that the demand, when time is 100 days, it decreases by roughly between 4 and 5 units per day. That's the meaning of it. I like to wrap up this section, but please look again at problems 26 through 60. Please, anything you would like to see, 26 through 60. They're all different. We can spend 3 days on just that particular page.
33.
So very good. Let's look at 33. Where are you? 33. I see it. Okay. 33 is an easy one because we already practiced this, and I hope that everyone is in the clear with. Oh, yes, I'm copying. Yes, okay. I'm going to copy 33. Sorry. You said 33. Okay. So let me do this real quick. We bring 100 in front. Then everything will be 2x to the third minus 3x squared plus 4x plus 1 to 99. And then multiplied. You have to continue here, but of course, you know me. So this is 6x squared minus 6x plus 4. I would normally pull out a 2 and multiply in front. I would recommend that. You will see why in the next chapter. So 200, 2x to the third minus 3x squared plus 4x plus 1. And now I'll multiply by 3x squared minus 3x and plus 2. Yes, sorry, my apologies. Yes, you did say 33. I copied 35 for some reason. Very good. So g of x, this is a very good one. Thank you. So 3, the one you chose, not the one I chose by mistake. Okay, perfect. This is a very good one. You notice how I always simplify the function as much as I can? I don't like this. I like this. I don't want to use the quotient rule when I have nothing at the top. Then I have to multiply by 0, and who knows what else can happen, right? So same thing here. I don't like this, but I like this very much. What power is the square root?
1/2.
That's it. Great job. I don't want to differentiate this. This is difficult. This is much easier. Okay, so then G prime. Can anyone help?
Can you answer one thing real quick?
I couldn't hear you.
Can you answer something real quick?
Oh, yes, of course.
Why is it 1/2 the power?
Okay. The nth root of a to the mth power changes into an exponential notation with a fractional exponent. The index is always the denominator and the power is always the numerator. The index here is 2, is the only one we do not write. And the power inside of this fraction is 1.
Okay.
Good. So G prime, can anyone help with G prime? What is the starting point?
Would it be 1/2?
Yes, we have to start with 1/2. Then what happens? After we put 1/2 in front, we continue with what?
3 plus 2x over 5 minus x. Negative 1/2.
Very good. Times. What do we do next? That's okay. You have not seen this before. So what do you think, anyone?
Would it be?
We'd use the quotient rule now, right?
Brilliant. Absolutely. I have to differentiate the inner function. I would write 5 minus x squared in the denominator right away. And I have to use the quotient rule. 1 prime times 2 minus 1 times 2 prime. What is the numerator prime?
2.
Excellent. Times the denominator. Minus the numerator times the denominator prime. What is the denominator prime equal to?
-1.
1.
You saw what I did for laziness? I didn't want to put -1 here. I just changed the sign. Now, remember what happens when a power is negative? I flip. So then I have 1/2. I flip into 5 minus x over 3 plus 2x. And now the power becomes positive, and I can put it back. Now here I have to perform the calculation. So this is times 5 minus x everything squared. This is the 10 and minus 2x plus 3 plus 2x. Thank you. Those two go away. The 13 will go in front. 13 over 2 times this in the denominator because the numerator. So the final form. Very good pick, as I mentioned a few minutes ago.
Wait, why are you multiplying 1/2 by the numerator?
Why am I multiplying 1/2 by the numerator?
The 13 on top of 5 minus x squared.
Yes.
You're
So-
taking it in front of.
So I have 1/2 times something times 13 over 5 minus x squared. 1 times something times 13 will be 13 times something. 2 times 1 times this will be 2 times 5 minus x squared.
I see.
Okay? Can I erase it now so I don't confuse anyone? Okay, so then I have 13 divided by 2. I can write better. I will put 13 in the middle. I'm going to erase the first one. 2, 5 minus x squared, and then the square root. That's the nicer simplified form. Very good pick, actually, as I mentioned several times. Good. Anything else from those problems? Anything? 26 through 62.
I had a general question.
Yes.
And it may sound a little dumb, but these questions have a lot of steps. So
I
is there
know.
anything
I know.
that we can do to avoid making like a small mistake?
I
Or
know.
that you've noticed like a lot of kids make a mistake on?
Yeah. I can only say practice. I really can't say anything else. It's a very good question. Very good
So
question.
There's no like easy way, like with the derivative.
The way I show it, I think it's the absolute easiest way. Try to simplify the function first. Change powers if you need to. Don't allow traps like a number over x to the third to differentiate. No, change it immediately into a product. It's a constant in front, which doesn't affect anything. So, yep, it's all about practice. Sorry. Yep, I agree. Okay, moving on. So I think we have enough, but if you find other problems, please do stop me. I would like to present the last section of this chapter, which deals with higher order derivatives. And this is it, chapter 1. It took me like, what, 2 months or a month and a half? I know I'm slow. Higher order derivatives. I'm slow because I want communication with you. I don't want to leave anyone behind. Okay. So what does this all mean? Well, when we talked about this, we really meant the first derivative. For example, if I have a distance formula or function, and if I differentiate the distance, I get what? Anyone? What is the rate of change of distance with respect to time? What will that be? The average.
Speed?
Very good. Velocity or speed? Very good. What if I want now to differentiate velocity? So this is the first derivative. First derivative, the first derivative of the distance is the velocity. But now the derivative of the velocity will basically be the second derivative of the distance. What will that be? What do you think? The rate of change of velocity with respect to time.
Acceleration?
Thank you. So in short, if I have s of time, which is the distance, then I have v of t, which is the velocity, and a of t, which is the acceleration. This is s prime of t, and this could be either s double prime of t or the first derivative of the acceleration. So again, this is distance, this is velocity, acceleration. So let's look at a problem. Of course, we can be asked to determine the rate of change